The 10th question that we have is again an interesting question. We've been given two spheres of radii r1 and r2 cut orthogonally. We need to find out the radius of the common circle. So for solving this question, let us use an analytical method. Let us assume the common circle to be equal to x square plus y square is equal to a square and z is equal to 0. That is, it lies in the xy plane. Its z coordinate is equal to 0. There is no loss of generalization over here. We are using the analytical method to solve here. So now let us write the equation of the two spheres, which will have this as the common circle. Now since the common circle of both the spheres is this, therefore the z coordinate, there will be only z coordinate for the two spheres, that is the x coordinate, and the y coordinate of the center for the center of the two spheres will be 0, because the x coordinate and the y coordinate of the center of this circle is 0, 0, 0. Now let us write the equation of the sphere 1. This will be x square plus y square plus z square plus there will be no term of 2ux because the x coordinate of the center of the sphere is 0. Therefore there will be only a term of 2 lambda z plus some constant is equal to 0. Now since this circle is a common circle for this equation, therefore on putting z is equal to 0 we must get this, that is, this should be equal to minus a square. And similarly for sphere 2, we should have x square plus y square plus z square plus 2 times mu z minus a square again equal to 0. Now the radius of sphere S1 can be written to be equal to root over lambda square plus a square, and the radius of sphere 2 can be written to be equal to root over mu square plus a square. That is, this is written in the format when you find out the center, that is 0, 0, minus lambda, and this is the constant term. So you write 0 square plus minus lambda square minus the constant term, that is root over lambda square plus a square. Therefore the radius of this circle r1 is equal to root over lambda square plus a square, and the radius of the second circle is root over mu square plus a square, and that is equal to r2. Now we know that the condition for two spheres to cut orthogonally is 2u1 u2 plus 2v1 v2 plus 2w1 w2, where u1 u2 v1 v2 v2 and w1 w2 are the coefficients of x, y and z in the two spheres respectively. This is equal to the sum of the two constant terms. Therefore applying this over here we get u1 u2 v1 v2 are 0, therefore 2 times v1 is lambda into mu. This will be equal to minus a square. So therefore we get lambda square into mu square is equal to a to the power 4. Now let us solve this equation that we have. We can write lambda square as r1 square minus a square and mu square as r2 square minus a square. This is equal to a to the power 4. Therefore on solving this we get a square minus of a square times r1 square plus r2 square plus a to the power 4 plus r1 square r2 square is equal to a to the power 4. This is r2 over here. Now on solving this we get a to the power 4 cancels, therefore a square into r1 square plus r2 square, this is equal to r1 square r2 square. Therefore the value of a can be written to be equal to r1 r2 root over r1 square r2 square upon r1 square plus r2 square. Therefore on solving this we get the value of a to be equal to r1 r2 upon root over r1 square plus r2 square. And this is the final answer for our radius of the common circle. You can also remember this result for solving the questions faster.